Hello everyone, today we'll talk about the problem number of islands. We're given a rectangular grid of ones and zeros, where ones represent land, and we're interested in counting the number of islands. When two land tiles are such that you can get from one to the other by only going up, down, left, right and never going into the water, then those two land tiles are part of the same island, otherwise they are a different island. For example, in the first example case, this whole thing is a single island, and there is nothing else, everything else is water. Here we have an island here, a single island here, and also an island here, so the answer is 3. Whenever we see a grid problem, one thing we can do is think about this grid as a specific type of graph. So a graph where every vertex has at most 4 neighbors, up, down, left, right. And in this case, if we consider only those ones to be eligible vertices, then our problem becomes just the problem of counting the number of connected components, right? The number of distinct parts of this graph. And there are many ways to do this. Probably the simplest is to use your favorite graph traversal method, for instance, depth first search, so DFS, and just go through the graph. And every time you encounter a new one vertex that hasn't been visited yet, then this is a start of a new island and you have to mark all the other ones as visited. And of course you do not have to explicitly construct this graph. You can just operate on the grid, go up, down, left, right. But the idea is based on thinking about graphs. Let's see the example implementation. We start with a standard boilerplate for dealing with grids. So we have height, width, and we have all the 4 directions represented as a list of pairs of changes to x and y coordinates, right? Row and column numbers, as I'm used to calling them. And what we want is a sum of our DFSs for every tile on the grid. And now if the tile is made of water, then there is no chance for any island, and we just return that this is not an island. Same thing, so if it's outside the bounds or if it's water, we return 0, otherwise it's a land tile. And we have to start marking all those tiles as visited. One way to do so, if you're not concerned with destroying the input, is to simply sink this land tile, change it into water. And for all of our 4 directions, we try to process it. Of course, we don't add anything else to the result, we only return 1. So the 1 is going to be returned for exactly the first tile that we encounter in this grid that is part of this given island, and everything else will just be sinking all the other land tiles that are connected to it, but not adding more to the result.